Hello, and welcome to the talk, Your Best Buddies. I'm Krzysiek.
And I'm Krzysiek as well. I'm Frodo.
Surprisingly, we will be not talking about ourselves. We will talk about the learning process. So, Krzysiek, let's imagine the situation. You are new in the project, and you were assigned to tackle the very nasty bug. And you really don't know you know nothing about this project. How can you approach this problem? So, what are the sources that you can gather the information about the project?
I will ask you.
Oh, that might be. If I'm familiar with the project, okay. That might be what the other
If there's no one or I'm introvert or in the evening, I will just go through the code, cry, go to the documentation. There is no documentation, cry more. So, can you help me?
Yeah, basically. So I did the small list in top to the bottom approach. So on the very bottom, there is a source code, because the source code is the ultimate source of truth in our case. But we have also other sources. Like, for example, we can ask our coworker. We can also dig into the documentation. We can track and see what we have in our issue tracking system. We have some version control system as well, so maybe there is some useful commit message that we can use. And of course, there's a source code. So the future looks bright. We can dig into that. But unfortunately, there are some problems. The problems like the coworker who was responsible for implementing that part of the system is no longer working in our company, right? In IT, we have pretty awful ratio rate. So basically, that may happen. Also, in big company, you can have some problems how to find the right person to ask the right question. Spoiler alert, there's a context body that can help you here. Documentation. Documentation has its very own problems. Like, the documentation can be in PDF, in Confluence pages, in wikis. So finding something that is related to our source code is really tricky sometimes. And we often do that in the I'm feeling lucky manner, right? Maybe I will find something useful. Issue tracking system. OK, it's closer to our code, but still, some projects can be already archived. Some issues, there might be too many issues to dig into. The description is short and not very useful. No information about the solution, or sometimes we don't have the connection between the issue tracking system and the actual code, so no merge request link. There is also a version control system, and it is the closest probably thing, the abstract but still closest thing to our source code. And in fairly standard project, I do believe, it's like we have 50,000 commits, right? But then we have more than 2,000 commits that are that include the names like refactor, rename, move, or remove, for example. So that breaks our history. So it's very hard to dig into that. And of course, we have some commits that are not particularly useful, like fix more than 100 times. Yes, but there is a hope. Spoiler alert, there is a context body to help you here. There is, on the very bottom, is the source code, and we all want to have it in that way. So it's very pretty, very standard, and well-structured. But in reality, it's rather like that. It's poorly structured. It's 5K long lines, complicated dependencies, and it's quite hard to figure out in which part of the system we are and how to actually integrate a new feature. But spoiler alert, there is a graph body to help you here. But on the very end, it boils down to working effectively with the code. And we are working with the code in our IDEs. So let's take a step back and look to the past on IDE's evolution. The first IDE, let's call it IDE, for me was a Turbo Pascal. I was born in 1991, but I was using that in the high school anyway. So that was pretty amazing, like syntax, highlight, it was there, some menus and stuff. Then we had this very nice IDE in Poland called Pajączek. How many of you are familiar with this Pajączek IDE? Yeah, a lot of people. It was really nice. It has like integrating feature like HTML files, so you can code it also in PHP and JavaScript, and render the page on the fly. We have Eclipse in 2001, so the dedicated IDE for the Java. Then we have also the Intellij, right? And the main feature of the Intellij we all know was the dark mode. We all know that. So yeah, 2019, not very much has changed, actually, if we will look at the first glance. So it was like 20 years journey. So what really has changed? Oh, we are improving, basically. So we are putting into our IDEs various integration, like integration with the Docker, with Git, and others. We have this new cool initiative of language server protocol when we can implement multi-language support very straightforward to different IDEs. We have advanced language support like refactoring, smart completion, and also suggestions. There is a push in our space to actually move it and make it more smart, make it smarter. So also base those suggestions on some AI mechanism. And after all, we are improving existing tools, but we are also trying to gather more and more context to our IDEs. And there is still a lot of places to improve.
And then your servers are on fire.
Yeah, can you help me with that?
There is a null pointer exception. And you fix that.
Crap.
You add one missing case. And then you try to refactor the thing, try to find what was the cause of that. And after digging the code, you found something like this. This was actually found, I think, in the early 90s, somewhere in the early 20th century, somewhere in the States, and they has no idea what was that. It was made by living creature because it's like way too symmetrical. It looked like a big corkscrew, and you have no idea. I'm pretty sure every one of you sees something like this in the code. Let me show you maybe not an example, but let me show you how we work right now with the history. So this is a nice connection because this is a Zinc code base. The code base that Eugene was telling all us about for like 40 minutes. And this is quite the old software. It was created by Mark, as Eugene mentioned, and it was wrapped by many people. There was like 3 or 4 waves of Zinc contributors. And then we got this method cycle. This is the heart of the Zinc. This is the piece that actually computes the changes and runs the compilation. And there's a few things I want to know. Like there is this X class file manager. Looks like X-Wing from Star Wars a bit. What's going on here? There is external lookup. What's going on there? And I got some problems. I want to analyze where are those problems comes from. So I can use git blame. And what it gives me? It gives me 2 things. Here, pop-up show. It's just adding X as a prefix. So not an important change. Here, it's standard thing in the big code bases. Refactor with ScalaFMT. I can, of course, go back to the history and do it manually, but is it the way how we actually do it in the 21st century? No. There is something that is called context body I want to talk to you about that adds a lot of colors into the screen. I hope that you are able to see that because we are not optimized for presentation mode and we are not optimized for this projector. So keep in mind there is a lot of different colors, and each of that colors represent a commit. And as you can see, the commit here is completely different than the commit that is given by Git. Why is that? Because in context body, we care only about meaningful changes. We care about history for given token. As you can see here, hopefully, there's a different commit assigned to X class file manager and different commit to class file manager. Why is that? Because in context body, we track the history for given commit, for given token, which allow us to actually preserve history across refactors. And we're also working on new cool features. Actually, we are with that information. We are able to preserve history across moving stuff between files. So if you got a class, you can move it to different file, and you can keep the history of that class. So no more losing history during the refactorings. And also we will support renames and other crazy stuff, so the history will stay with the code. And yeah, the scientists also figured out what was that thing. It turns out this was a burrow of little creature called Paleocastor that actually dig deep into the ground because it was safer, it was warmer, and then the sun blows in and actually fills these holes and fossilized. And this is hard. I mean, this is a guess, and we still don't know how, for example, this paleocastor might look like because there's only a bones. And in terms of the code, if you think about your applications in the code, your code is also like a bones of your application. So it actually gives you the structure. But if you look at the code, you might be able to imagine how it would look like. But you are not looking on the incremental compiler. You are looking at something that makes the incremental compiler. And the same goes with the bones. So we know T-Rex, and it looks like this, but we have no idea, or maybe some, if this doesn't look like this one. So maybe it got feathers, and you can make really nice scrambled eggs out of his eggs. We don't know. So how the scientists actually figure out this kind of stuff? So they rule out there's no chicken. I will show you in a second why. There's something that is called the trace fossils. Alongside the bones, we also have different marks of the occurrences of the dinosaurs in the wild, like footprints. So with that, we can actually see how big the footprints was and actually try to match the bones there, and we got some more data. There is stuff like poo that was fossilized, or even skin. This is actually T-Rex skin, apparently, so there was no feathers, hoof. Because if it is a chicken, it will ruin my childhood. And we can do that, the same thing with context body. So let me show you a different repo. And here, as you can see, there is like some stuff. There is a map that was changed at some point. As you might not be able to see. I will highlight this change. Maybe it will be better. This one. The only change in that file, like recently, was actually editing this mutable map. So this line in the bottom should not be affected. But every test passed, and on the production, we got like really bad times. Why is that? First of all, we are not using functional programming here, so that's probably the first case, but now we have to fix it. What's going on? So we can take a look on different side of context body. We can take something that is called symbols. And with symbols, and we can again highlight the commit because we are unlucky and the codes were similar, especially on that screen. And as you can see, the changes was in two places. The changes was in the here and here. What happened? Actually, if you go to the code, there was an global import for mutable map that was removed. So here was an immutable map, which means the default that you want to cache was computed every time. And without this information, without this being able to see, it's like it was this example is small because everything is close to each other, but it can be way, way worse. But that's not all. We can go to, for example, and we can see other traces of the code, and we plan to implement way, way more. One of those things is the traces, origins. So it's actually in the current form, just like really raw, but this is the jar where given dependency comes from. I don't know if you ever faced the problem of actually leave dependency hell. I wish I got this kind of tool with me, so that is why I implemented it. And the last thing I want to show you is, is synthesis. I think I'm saying this correctly. Basically, implicit types, everything that is not there but is a code. Let me show you. So for example, here, we know that there is a collection breakup. So we play with the implicits, but there's actually other implicit parameters added here. The same goes with map, and we can see there is applies or types. So this is also useful when you want to okay, there was no change in the file, but behavior change. Okay, the implicit change, and we can track it down. So yeah. So that's it. And if you want to play with that, it's finally open. You can go to contextbody.virtuoslab.com, and there is instruction how to install that. We are on our way to Intellij plugin repository, and sadly, by default, we don't offer these traces, these types and everything. We just offer simple history based on tokens. But stay tuned. Next releases will bring it because it's working, but it's not as reliable and as ready to use it widely as we want it to be. So, with that said, I think it's now time to meet the other body. So we meet the context body, now it's time for graph body.
Okay, so let me introduce the idea. Idea behind the graph body is actually pretty simple. So imagine that we have these classes, class A, class B. There is some connection between them because the class B has a parameter of the type of class A. So clearly, if we will look at these two files and two classes, we can draw something like that. So the nodes are the definitions, and there are some relations between those nodes. So we are starting to build the graph. And we can do that let's say, pretty easily in Scala, not so easily actually to be very precise and very correct, which what Rory was talking about, actually. So it's pretty hard to have the precise and correct graph for our whole project. But in theory, and to have, let's say, some understanding and correctness of the graph to some level, we can join the IST, so Scala trees, for example, or the ScalaSphere IST, and information about. So we are getting information about the code structure, and we can take semantic DB to have some information about the semantics, and also have stable, unique symbols across all the files, which will allow us to connect different nodes together. And of course, we can also ask context body about that, because if we will focus only on AST, Scala trees, and like semantic DB, we will be restrained only to implement that in Scala. And we aim context body to actually be language independent. And this graph is a representation, an abstract representation, so-called abstract semantic graph, that shouldn't be language dependent. It's just a higher level of an abstraction than AST, and we can extract from this like very useful and different information. For my purpose, actually, I'm trying to visualize something. So I don't need very precise graph because I don't want to change and manipulate the code. But I need to visualize something. Why? Because I want to provide the developer with some additional context about the project. For example, if you are coming to the new project, and you will take all the classes and dependencies between those classes, so the references, you can draw some map of the project. This is a very simple project, but as you can see, after a few tweaks in Gephi, we actually can find some community groups, like this comments module, or this analytics module, or some user service related stuff in our project, right? So we can reason about the project and basically tell something just based on the source code. So we don't have any other documentation. How it works on real project, let's see metals. So I parsed the metals, I generated the graph, put it into this Gephi, and I was able to generate something like that. So it was a good start for me, because I knew that the metals language server is like a main class here. There is a metals HTTP server also, so probably if I want to implement some additional feature to LSP, I should look into this class. There is some configuration as well, and maybe something connected to semantic DB, right? So there is a module that operates on semantic DB. Let me show the demo. So we're trying to bring this context as close to the source code as possible to, so let's say, to our IDEs. So for example, I can generate the graph for this very file. It's one level of the graph to just not go into deep and just to be able to reason about this graph. And if I will click here, for example, for the race, it will also go and move in the source code. Because it is a graph, we can put here like other information as well. So for example, some information from the Git. I'm not sure if that's visible. Probably yes. So we have the kind, so it's an object. We have some package. We have a commit author, the first one who introduced this class here, or this object here, some commit message and the date of the commit. You can imagine that we can augment that graph with additional information. For example, how many times this per second this very class is hit on the production, right? Just need to generate some logs and put it here. That would show you how important is this class in terms of the whole system, and if you should really be like careful about it, or maybe not really. We have like different layouts as well, just to help you. A few features, additional features like freezing the graph, so you are not able to change anything here. But the nice feature is also when you can like poke here, for example, and you are going through the code, and this graph is automatically loaded, so it preserves the context. It preserves the context for you, and you can, let's say, in next release, I hope we will add something to store this graph, and you can like take this graph also to the merge request, and that will be some additional information for the reviewer. We have some working integration also with Visual Studio Code. Let me try to show you. Okay, so we have like the class here. Let's say is pretty complex. We can try to visualize that class. Yeah, so that is a graph. Of course, when we will do like bigger analytics outside of this IDE, maybe that will be useful to extract some modules, to show the modules, or do other stuff with that. For now, it's not very useful, but what can we do? We actually can untick those not relevant nodes that we don't want to have, regenerate the graph. It's working like that right now. It will be improved probably. And we have the graph of the classes. And that is probably something more readable, and that's something that can bring some value. Also, we can add, for example, the object here. There's a possibility also to remove some nodes if you don't want them, to clutter your image. And additional features like, for example, finding the path between two nodes. So, for example, find by IDs the class and the HTTP server. Let's hope it will work. Yes. So we have found the path between the two particular nodes. Of course, we aim to be able to find the path from the left-hand side of the system to the right-hand side of the system. Sometimes when you are debugging and you are trying to find the connection between different classes in your system or the methods, it's not it's not easy, even if today's support and IDs. And there is more to come. So those were the GIFs, just in case the demo went wrong, but it worked. But I wanted to show you one more thing. So as we are approaching virtual reality, probably we can also do something like that and have the graph in 3D and do some insight on this as well. We will for sure push the idea, and we will see how it will work. So to sum up, we have like three main areas that these graphs can be applied. We have learning about the project, so project visualization, project evolution. We have refactoring, but actually to refactor something and change the code, you need to have very precise graph, and that's what Rory is doing right now. So I hope that I will be able to just take his graph and apply to my project. Yeah, and maintaining as well. So you can imagine that the graph has some structure. We can have some fitness function over it, and when you're pushing a new code to your repository, and there is a CI plugin, it can detect that the structure of the graph was changed significantly. So that means that probably maybe some new joiner added some crazy dependency to the other part of our system, and that's not what we really need. And that will be it about graph body.
Yes, and Krzysztof mentioned that the context body can help with providing data. And how does it happen? I mean, context body is about context and history. So we were like sitting in the kitchen in our office and chatting, like exchanging what kind of problems do we have, and we find out that we got the same problem: integrations with stuff. I was struggling with integrating with ScalaSphere, he was struggling as well, parsing semantic DB was not easy, and then I realized there was the same problem out there. Like the LSP is trying to solve the same kind of problems. There is multiple language, multiple editors, and everybody has to write its own integrations. So I decided, okay, Krzysztof, focus on the graphs, and I will do the hard work. And I decided that context body will not only be the platform, the context body, the guide for you, but also we are trying to turn it into a platform, actually, to extracting data. why is that? Because in many cases, you don't need to build tools. You don't need data that are really specific to the code, to the ScalaSphere. In case of graphs, just a graph is required, and graph is basically a matrix that can be exported. So the graph for TypeScript and JavaScript and Scala and other languages would look exactly the same, maybe with like small details like what kind of type of the node it is. But in terms of the actual important stuff is always the same thing. And more, the context body was always designed and always thought. I was talking about smart history in the beginning, but this is not all what I have in mind. In order to be able to grasp context not only from the code, and this is what I also want to expose. The data that comes not from the code, the other traces, not only from code, like for example, you can attach to the given code the unit test that fails because of that code. Or if the code goes into production, you can like find the change of the source set and try to feed into the context body data from how much load is generated, how much latency it was, or what other exception was thrown, or like any specific logs. That is why context body is not focused on ISTs. It's focused on other model that can describe code in I hope with the same amount of information, but not focusing for any specific language. And there's the end goal for the context body is related to the story I've heard in Peru. There it was like they were old and you were like, for example, building walls. If you are got like 40, you are no longer building the stuff, but you rather were like teaching young guys. And this is a heartwarming story, everything is fine. But I was like, listening to that, I realized we do the same stuff in IT. I mean, come on, the senior developer, when new guys come into the project, has to actually guide them, and it takes a year, a month, 2 weeks, sometimes 3 months, to actually for the developer to pick up at the speed and being productive in the project. I was thinking, why we still are in that, realm of this really maybe not that advanced civilization like Incas? Why we still have the bus factor? So when that developer burns out and leaves the project is doomed. Or as Kuba nicely put, the conference factor, so how many developers has to go to the conference so the projects can no longer be maintained for that amount of time. And this is actually addressing this problem is the ultimate, I would say, goal or for the context body. So actually being able to store and build knowledge about your code and be able to replace us humans being. So there is I no longer have to be there so that my project is maintained. So someone can ask context body to actually show you the way. And this is a really ambitious goal, and I want to start small. So I start with smart history because the model I was building actually gave it to me for free. And I expected to finish the integration with IDE in a month, but this is super hard. IDE integration and integration with user that is interactive is super hard to make. So we're still finishing up and cleaning, but as I said, you can go to contextbody.virtuslab.com and play with yourself. I know it might break at some point, but I'm really looking for a feedback. But the next actual goal into going to the building the project base is trying to find an expert to talk to. So you are new in the project, you open a class, you have no idea what's going on, just select a piece of code, ask context body, tell me who I need to talk to, and you got a list of the guys. That's my step. That's the first goal. And it's almost for free, give us the reviewer suggestions for the PRs, because basically you can select all the PR. And one of my colleagues maybe Bartek is here, yes, he's there. He's writing a master thesis about Dust. So there is some guarantee that it will be shipped, I hope. And yeah, more stuff to come is learning from the mistakes and I think I've got some more time, so I can go into more detail here. So I was doing some proof of concept here, and I learned that the code that lands in the repository that is there provides just a small piece of the information, of the learning, because this is the happy path. This is the code that survives all the testing and everything. The actual knowledge happens when you develop the code. And we are on the good path actually to being able to extract that knowledge as well. Because we are plugging into IDEs, we are plugging into compiler, we are missing few more integration. Like for example, okay, this was the change in the code, it compiles and 2 unit test fails. Or you have to change parameters in the run application in order to make it work. This is the kind of small things that blocks people for a long time. but you have to fix the mistake actually to be unblocked and move on, and this is not the knowledge that gets committed with the code. So this is where we plan to get the information, and I hope this will boost our knowledge gaining quite a lot. And all this, what we are checking, maybe you noticed that both context body and graph body got similar icons. And this is done on purpose. Actually, context body and graph body are like two-thirds puzzle of the bigger thing that we are working on with Krzysztof and other guys from our team. Actually, we are building the semantic platform that will integrate, probably over context body or over something else, tools like context body and graph body to provide a nice suite with nice logos, of course. And so you can explore your code, and you can be more productive. Because let's face it, like the economy and the needs of the software product is like growing way more than the amount of developers that we've got. Of course, there is like perfect way to get new developers. For example, we need to increase the amount of increase diversity and bring in, because there is like a lot big potential of the new developers. But still, it will be not enough. I think we need to be more productive, and this is what we want to address.
And from the stage, let me also thank you all the developers from Virtus Lab that are involved in this project. You all know to create something useful, it's not it's not very easy. So we have plenty of support in Virtus Lab. Yeah, so big thank you.
Yes. And that's all. I think we can take some questions.
Yeah, thank you.
Thank you very much. So the first question is, can the graph be exported as a part of a release, for example, as a part of a contributor guide?
Yes, definitely. So that is something that can be also, it's a part of the release, right? Could be, just to see the project, but it also be a part of the merge request, for example. Just to, for example, sort the files in right order. Now it's sorted more or less alphabetically if you are on GitLab or GitHub, but you can take and sort them in the descending order based on the graph order, and also it can be visual information what actually has been changed in your project when you are doing the merge request. So I think yes, and the other thing is the evolution of the project. So imagine that you have a new graph per commit, so you can go through the whole history. That's a similar thing that context body is doing. So basically, to generate this nice history, context body has to go commit by commit to find for example, who introduced this token. So by the way, doing that, we can also generate this graph and yeah, try to do pretty nice stuff with it.
And context body generate the graphs for all the commits back as well, if it's run correctly.
Yes.
Okay, so the second question is, can we use graph body with TypeScript?
I think this is the question to me. The TypeScript is the language that we want to support, because we don't have integration with the TypeScript compiler, but we got the TypeScript guys that are really lagging to have TypeScript working, so they can, write the code in TypeScript and see the result immediately. So I think just after the conference, when the dust settles, we are sitting down and writing TypeScript integration.
Yeah, so the key thing is that to visualize something, the graph does not have to be very precise. So we can do that also in context body, as we are targeting that to be language independent.
Yes.
Okay, so the next question is, how hard would this be to integrate this into a PR process? Exposing this info though would be awesome.
I think it's to your question.
Yeah, I've already partially answered that. Shouldn't be that hard. Shouldn't be that hard. You just need to find those tokens that were changed on this merge request, what we have in context body, and maybe just filter out all the other noise from the initial graph, and that will be it. Of course, manipulating the graph, filtering out, especially when the project is huge, it's very problematic. For example, I wasn't to index even a small project. I wasn't able to get some databases working with it because it took too much time basically to put it into database. So I'm just storing that into memory just to be able to easily extract the nodes if you need that. And yeah, working with huge graphs is a pain, unfortunately.
Okay, thank you. So the next question is, will it handle big legacy monolith code bases?
Context body, yes.
Yes, graph body as well. So from the history, the initial idea of this project, when I started working on that, was that we went to our client, and the client had like monolithic the code base, and we've been asked the question how long this will take to separate one module from the other. And it was pretty complicated to answer that. And what we did with my colleague, Pavel, overnight, so we implemented like a short script to extract the packages and the imports. And we've built the graph based on that, visualized that on Gephi, so on this project. And we've been able to go to the managers and show them that there are different modules, like for example plugins that are binding those two, and there is a huge base of something that should be extracted to the common library. So that was help for us, and yeah, it started like, can we do better? So can we extract those modules automatically? But that, as Rory mentioned, is not so easy. So I pushed the idea slightly to the left.
Okay, so the next question is, what will be the impact of Tasty and Dotty for graph body?
Ooh, that probably
So
is
it's just another integration. So it's the once we got it, and we should get it quite quickly, either through semantic DB or we will see what is done in metals and just copy the solution, because we need pretty much the same information as metals. Add some formal stuff we need to add, probably some maybe compiler plugin or just parse Tasty. But yeah, it's just a matter of we need to implement that.
yes.
Because there is nothing
It's
blocking.
now working with Scala 2.12, 2.13, right?
Yes,
It's not working with 3.0, so with the Tasty. Maybe that will be much easier.
If you want
to
to
implement
help
it
us
twice.
and try to provide this, like talk to us. There is an option to help.
Okay, so can the graph be generated from part of the code, for example, some module or package?
Yes, right now, even in the IDE, there is an, I can show you, there's a support for indexing the graphs. There are two modes, basically, so we can index only some module. It's not a rocket science, because basically you can parse every file, like you extract the AST, and you can generate the semantic DB for a whole project, but you can index only some part of it. And what's more, you have also this option here to reindex something in add mode. That means that if you have like two IntelliJs with different projects, but those are like somehow connected, you can index one, you can index the second one, and then this graph will contain the changes from both projects. So we will be able to walk through the files which are in like to separate IntelliJs, or even in you can have like the third one in Visual Studio Code, and that should work as well. Yeah.
Okay, so there's the feedback that someone loves the project.
Oh, thanks.
Okay, so the next question is RDF and knowledge derivation.
Yes, probably. We will see. We will see. Like first, we need to get a huge amount of data. Then we need to build this model to suggest people, and then we will play with data and get the knowledge structured. And also, probably need to find out what we need to get out of that data. So, long way ahead.
Okay, so there's a question whether you have considered some repository with code property graph. I know if you...
I'm not familiar. I will take a look.
Me too, yeah.
Okay. So do you think about using graph body as a compare instrument for huge refactoring?
Yes, it can be, but if the refactor is huge, the graph will be also huge. So that means that you need to think about it, how to make it useful, because I'm not sure what features can we provide to
But we can, for
have this
example,
comparison.
I didn't mention that in the presentation, but I also want to use graphs to visualize stuff in context body. So you can, for example, add metrics from the graph in the code and see how this affects given class. So how many connection comes, like what is the flow and stuff like that.
Yes, yes. As far as if it's huge, we have to work with the huge graphs. That's the problem.
Yes.
Okay, and so the last question is, does context body work only with Git?
So far, yes, because it's the most common thing, but actually it's not tied to Git. I mean, we can just implement abstraction over getting information outside of Git, and it will just work. But like once we got first, a lot of interested people in that, they say, okay, we got Mercurial and we need to support, then we probably can implement that. Because in the platform itself, we require Git for our own internal stuff, but not from the client's code.
Okay. So, and there's also the feedback that you've got your first on GitHub.